Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I will be going over another problem involving solution chemistry. So just to remind ourselves about solution chemistry, this is where you are given molarities and you're given volumes and you're given a balanced equation and you're asked to figure out, find some information or find a volume of another reactant, or maybe you're asked to find the grams of a product or something of that nature. So in this way, this is the road. This line here, I call this the chemistry superhighway, the chemistry conversion superhighway, and this is basically the main roadmap that you are going to use when you solve problems, and you want to get onto this roadmap. And depending on the problem, depending on what they give you, you can get onto the road in various different ways. The way, when we're doing solution chemistry, the way you're going to get on the road is to get to moles from a volume. So they're going to give you a volume. You use molarity as a conversion factor to convert that volume in liters to moles, and then you can use the mole ratio in the balanced equation, and then from the moles, if they want another volume of this other substance, then you use the molarity to convert to a volume of that other substance. Or if they want grams, right, maybe they're asking for the grams of a product, then if you get to moles of B and they want grams, then you would convert using the molar mass. So depending on what the problem is asking for or what they give you, you can get onto this highway either from volume to volume, or you can go from volume to mass, or anything like that. So that's what solution chemistry is really about. All right, so our solution stoichiometry. So in this problem, problem number 2, we're told what volume in milliliters of a 0.15 molar solution of HNO3, that's nitric acid, will completely, again, there's that word completely react with 35.7 milliliters of 0.108 molar sodium carbonate solution, according to this following balanced equation. So here, because you're saying completely reacts, then you're assuming that both reactants react completely, so that there's nothing left over. So okay, so how do we begin this problem? So we're not going to start with conversion factors, and since molarity can be used as a conversion factor, we're not going to start there. It's asking for a volume of this substance here, the nitric acid. So that's where we need to get. We need to get the milliliters of nitric acid. So where are we going to start? Our best bet is to start with the other substance that they give us information about. So they give us 35.7 milliliters of this molarity of sodium carbonate. So we're going to start with the 35.7 milliliters because we're not going to start with the molarity. That we're going to use that as a conversion factor. So we're going to start with the 35.7 milliliters. So 35.7 milliliters, and this is the sodium carbonate solution. Okay, and we're going to put that over 1. And then now we need to convert. So we can't use molarity until we get to liters, because the molarity is moles of solute to liters of solution. So we need to convert this to liters first. And so to remind ourselves of the relationship of milliliters equal to liters, and you always put the 1, or I always put the 1 with the prefix, because I know what the prefix multiplier is. I'm going to put that with the base unit. So The prefix is 10 to the negative 3. So I'm going to put that to liters. So I have milliliters here, so that means milliliters goes on the bottom. So 1 milliliter of what? Milliliter of the sodium carbonate solution. And then on top I have 10 to the negative 3 liters of the sodium carbonate solution. All right, what's my next conversion? So now that milliliters of the sodium carbonate solution are canceled out, now I have liters. Now I can use the molarity of the sodium carbonate solution. So now I'm going to use this as a conversion factor. And so again, 0.108 molar means that I have 0.108 moles of the Na2CO3 sodium carbonate is equal to 1 liter of that solution, Na2CO3 solution. So that's my equality. So I have liters of this solution on the top, so I'm going to have liters on the bottom. So 1 liter of the sodium carbonate solution solution on the bottom, and I'm going to have 0.108 moles of sodium carbonate on top. So now the liters of the solution cancel out, and now I have moles. So now I have moles of the sodium carbonate, but I want to get to the volume of HNO3, the nitric acid. So I need to do a mole-mole conversion. So now I'm here, and I want to get to here. So I need to use the mole ratio in my balanced equation. So I have a 1 to 2 relationship. So 1 mole to 2 moles. So I'm going to put my next conversion factor. And so I have moles of sodium carbonate on the top. So I'm going to have 1 mole of the sodium carbonate on the bottom, and I have 2 moles of the HNO3 on the top. So moles of sodium carbonate cancel out. Now I have moles of the nitric acid on the top now. So now I have moles of HNO3. They want milliliters, so I need to get the volume. So now I can use the molarity of my nitric acid to convert from moles to liters. And so now I can do my next conversion. So moles, again, this is the same as saying 0.150 moles of my HNO3 is equal to 1 liter of the HNO3 solution. So that means I'm going to put this on the bottom, 0.150 moles of HNO3 and 1 liter of HNO3 solution on the top. So moles of HNO3 cancel out. Now I have liters of HNO3, but they want milliliters. So now I need to convert from liters to milliliters. So I'm going to use this equality again, but now I'm going to flip it. So I'm going to finish here. So I have liters of HNO3 on the top. I'm going to have liters on the bottom. So 10 to the negative 3 liters of HNO3 solution. And I'm going to have 1 milliliter of HNO3 solution on top. So liters cancel out, liters of HNO solution cancel out. Now I have milliliters of HNO solution. I am finally done with the conversions. So because I have milliliters of HNO3, they want milliliters of HNO3. So now all I have to do is calculate the answer. So that was a long problem, but we're almost there. So I'm going to take 35.7 times 1 times 10 to the negative 3 times 0.108. Okay, multiply that by 2. And then I got a 1 there, and I got a 1 here. So now I'm going to divide by the bottom. So 0.150 divided by 1 times 10 to the negative 3 equals, and I get 51. So the answer I get is 51.408, and that's milliliters of HNO3 solution. And so that is my final answer. Well, not my final answer yet. I've got to look at the significant figures. So we're going to eliminate, we're going to ignore the stuff that's exact. So here we have metric to metric volume, so that's exact. So we don't need to worry about that. We have the 1 to 2 ratio for the balanced equation, so the mole ratio, that's exact. And we have this liters to milliliters, that's exact. So we can ignore those. That leaves the 0.150, that's 3 sig figs. The 0.108, that's 3 sig figs. And 35.7, that's 3 sig figs. So it's all the same. So my answer should be in 3 sig figs. So 1, 2, 3. So I'm going to cut it off of here. And so this is a 0, that stays as a 4. So my final answer is 51.4 milliliters of the HNO3 solution. That is the volume that is needed for this molarity, of HNO3 to react completely with this volume and this molarity of the sodium carbonate. So I hope this was helpful, and if you enjoyed this video, if it was helpful, please share it with your friends. Like the video, put a comment in the comment section, subscribe to the channel, and hit the notification bell so that way you get notified of any new videos I put out. Thanks for joining me, and I will see you next time.